Hello friends, we are solving the question of engineering mathematics for tertiary exam. This is the question from the differential equation in which it provides the population of some particularly town with respect to t. The variation of the population with respect to t is given by a differential equation 1 by p t minus 500. This is your equation. Now, if you see this equation is become a very with a linear. If I am taking this side, it means dp to t minus 1 by 3 minus 500. What he become? He become as a linear differential equations. What he become? He become linear differential equations. Okay. Now, first he asking the time at which the population becomes zero. What is the time at the population becomes zero? So to solve the linear differential equation, how can I solve it? First, I found the IF integration factor. What is the integration factor? Is E minus e power q dt. And what is the e power? What is the q? Q is this. It means E integration 1 minus 3 dt. And what he become? E की power minus 1 by 3 t. Then what is the solution? The solution become y. What is the y? pt. pt multiplied by if, because it's a y. I am saying this is a y. So y into if equal to integration of q multiply into, if I am saying this is the x or c, this is x qx dt qx dt plus c. This is the solving procedure. Yeah, this is the formula by which we can solve. So what is the if? If is equal to y means p into t into e की power 1 minus 3 t minus 3 sorry t equal to minus 500 e minus t by 3 dt plus c. So if you solve it, what you become? I am saying just integrate it. So it's become e की power minus x means minus e minus x upon x. Okay, minus e minus x upon x. So it become directly I writing this e minus t by 3 equal to 1500 e minus t by 3 plus c. How can it come? E minus x, the integration of e minus x become e minus x upon x minus x. This is the integration of e minus x. Okay. So this is the procedure when you want to solve it, the equation. Now, so after that, this is the equation which we get. Now, what is the given? Is just given the population at initial time, the population of initial time at 50 at initial time. So the value of p2 is put in the equations which we got it by the solving the integration, right? So by the equations we find c equal to 850 minus 1500 equal to minus 650, because so put the c value in again in the equation, then equation become t, right? Minus 650. Okay, now what he want to find the population when at the time when the population becomes 0. We want to know the time. Then how can I find? I put the value of pt equal to the in this equations. So put the value of pt equal to 0, so it becomes 0. And what happened? 1500 into 1 t minus t by 3 minus 650. So 650 equal to, so when you solve it, so e t by 3 equal to 650 upon, we can say minus, right? We can say e t power 3 equal to 1500 upon 650. So when you solve it, it become, I'm saying I convert it in the, as a ln. So it become t by 3 ln 30 by 13. And when you solve it, you find t equal to 3 ln 30 by 13. So this is your the time at which the value of population becomes 0. And if you see the options, so B option is correct. Thank you.